Electric potential at any point inside the cavity inside a uniformly charged solid non-conducting sphere. You are seeing such a kind of non-conducting material as a sphere in which it is shown a cavity. Let me say some clue about the structure. The radius of this bigger sphere, the radius of the bigger sphere is r, and the radius of the smaller one is say some r, whatever it is. Okay, let it be r. And now what we have to find is, we have to find electric potential at any point inside the cavity. I am showing you such a kind of one point here, P, and I need to find the electric potential at this point P, which is lying inside the cavity. Structurally, O is the center of the big sphere and O dash is the center of the smaller sphere. In this situation, we are seeing, this one. This is the distance drawn from O to P as x, and this is the distance between O dash and P as y. Okay, O to x is P and O dash to P is y. O to P is x and O dash to P is y, right? So now what you must know before, the hint is, so in my previous video I shown you the electric potential at any point inside the sphere. Okay, at any point inside the sphere of a uniformly charged non-conducting body. Okay, so this is the uniformly charged non-conducting material what we are seeing, and here is a point P, which is here, right? This is the center O, and now if I say the distance between this O and this P is some say something like x, what we can say, so electric potential at P which is inside, right, which is inside given by, okay, it is rho divided by 3 epsilon O, and inside bracket it is 3r square minus x square by 2. Okay, so this is the hint that we must follow now in order to find the electric potential at any point inside the cavity. Well, so now we are putting our concentration to this picture. Okay, so let me say there is no cavity first. Okay, with no cavity, right, with no cavity, electric potential at P due to the sphere is equals, what we can say, this is something like this. In this equation what we have to make substitutions, r is nothing but the radius of the bigger sphere, right? R is equals r, substitutions what I have to make here. Okay, so in place of x, what we have to say, we have to put the value of x as it is, which is x, right, which is x, this is equals x. And what about r? R is not used in this situation, let it be. So therefore Vp due to the sphere is given by this equation, right? The same equation I must use, which is rho divided by 3 epsilon O, and inside bracket it is 3 r square minus x square divided by 2. This is due to the complete sphere. Okay, and due to if I assume this itself as something like this, okay, so this is just like assumed as a sphere of charge, right, assumed as a sphere of charge, what I may get like this, this one is the sphere, okay, like this. How it should be? This is O dash, radius is R, right? The point is here, and this distance is Y. Here is P. Okay, so only for this portion, the electric potential, okay, electric potential at P due to the part of the cavity, this one, where most of the charges are distributed like this, uniformly inside. So this is equals, what I must do here, for this I have to make the substitution, radius is R, this one, for this radius is R, and I have to make the substitution, x is equals y, x is equals y. So then what happens? It is rho divided by 3 epsilon O, and inside it is 3r square minus y square divided by 2, right? So this is the situation what I got now. Further, the electric potential at P, I need to find only the electric potential at P, right? So now electric potential at P, now electric potential at P considering cavity will be Vp, which is equals, so in this what we have to do, we have to consider the complete sphere and then remove this portion. So that means electric potential at P due to the sphere minus electric potential at P due to the portion of the cavity. So when I do this, so definitely during subtraction of these two, rho divided by 3 epsilon O, right, rho divided by 3 epsilon O will come out as common, and inside bracket what the things left, 3r square minus x square divided by 2 minus 3r square minus y square divided by 2. Okay, so doing further steps, Vp is equals rho divided by 3 epsilon O. What I have to write inside? So inside I must write, it is 2 in the denominator, 3 and r square minus r square, right, r square minus r square as 3 outside, and this becomes plus y square. That means what I must write, it is a minus, right, this should be minus, okay, so that should be minus, minus or plus, what it comes plus, right, plus into, it is a y square minus x square, okay, be careful, this is plus, and inside it is y square minus x square whole divided by 2, okay. So this will be the expression for the general expression for the electric potential at any point P which is lying inside the cavity.